Okay, so today I'm just going to quickly go through the method to generate a screw for a single screw compressor. We're going to do that within SolidWorks. Okay, so we're going to just start with a basic part. And first thing we're going to do is insert a plane. Okay, I'm going to do that 60 millimeters behind the front plane. Okay, and on this plane I'm going to sketch a circle, which is going to become our rotor. So I'm going to set that 70 millimeter radius. And then I'm just going to use that sketch and I'm going to extrude it to create a cylinder. Oops. So we're going to do that 160 millimeters. Okay. Then I'm just going to insert a plane on this end. And I'm going to make that coincident with the end face. Okay, so on this plane, I'm just going to insert a point at the origin. And then I'm just going to, plane 2, I'm going to insert another point. Okay. And then between those 2 points, I'm just going to insert an axis. Okay. So that's our basic rotor cylinder done. Now I'm just going to insert one of the points on the star. So I'm just going to sketch that. First things first, I'm going to insert a point, and I'm going to insert this at the base of the star. Call that 0. Okay, and now I'm going to build up our star point. Oops. I'm going to go up to 85. Just zoom out a little bit so we can see. Bring that across to 25. Bring that down 85 and then back to our start. So this is going to generate the complex shape on the rotor. So if we switch back to this view, I'm just going to create an arc on the front plane. So we'll make sure that arc goes through the center point on the rotor and also the point we defined there on the base of the star. And it doesn't matter what arc you sweep here, we just need to make a note of that number. So we've swept that through 355.7 degrees. So I'm just going to copy that. Okay, and the important ratio for the rotor geometry generation is the ratio of the number of points on the star and the number of flutes on the rotor. So for this particular design, I'm going to use 11 points on the star and 6 flutes on the rotor. So what we can do is using those two geometries we just generated, the arc and the rectangle here, we can do a swept cut. And rather than rotating the rotor, we're going to rotate the rectangle or the star point around the outside of the rotor body. So we're going to select twist along path and turns, and then if we go to our calculator, the ratio is 6 flutes on the rotor, and we divide that by the number of points on the star. So our ratio is 0.54 reoccurring. Then to get the correct matchup, we're going to multiply that by the number we copied. So the arc we generated, the number of the rotation that arc went through. I'm going to divide that by 360. Okay, and then we're going to copy that. I'm going to paste that in here for the number of terms. Okay. And as you can see, that has generated one of the flutes on our rotor. Okay, so what we're going to do now is take that that flute. We're going to also use axis 1, and we're going to create a circular pattern so we can generate all our flutes. So that is going to be 6 flutes over 360 degrees. Let me just do that, and now we can see we have our rotor with the profiled section generated. Obviously we can change the geometry on this. You can see here that this is getting a little bit thin. There's no OD section here, so perhaps the geometry needs to be modified slightly on the cutting tool, make it slightly thinner. That will give a defined outer diameter all the way around. But that's the basic method that's used for generating a rotor for a single compressor.